This is mad scientist Michael Ing here. Welcome back. I have a quick video to show you what I've done with my class today, my chemistry class. I want to show you the science behind a cold pack. A cold pack is something that you crack and you would put it out of the freezer and you would put it on your achy muscles. And what we do is that I want to tell you the science behind that, because what happens is that this is an example of an endothermic reaction. You need energy taken from the outside surroundings. So I want to demonstrate this to you. It's that I have right here a flask. Yes, it's a flask. And this flask, what I've got is I got a particle board from the construction room. And what I want to do is that we know that basic science here is that by putting this flask on top of this construction particle board is that it's unable to lift this up. So I want to find a ways that if we can get this to adhere or stick somewhere to this, that we would be able to raise this whole thing together. And I want to do that by mixing chemicals together, okay? Today, I have two chemicals to show you. A very classic example that very similar in cold packs. It's that we have barium hydroxide and we have ammonium thiocyanate, okay? So we have that. So the first one I want to show you is the barium hydroxide. And for the barium hydroxide, it is right here in this little beaker. So what I want to do is I want to pour that in here, and notice that this barium hydroxide is a solid. And so we're going to pour that in there. Excellent. Okay, notice it's in a solid state. Okay, now just by putting it on that, it still, as you can see, is not able to lift this piece of wood. So I want to find a way I'm going to sprinkle some water. So I got some water, doesn't matter where it came from, it could be distilled or regular distilled water, tap water. And what I want to do is I'm going to sprinkle a bit of this right here. So we put that right here, okay? It is my hopes that if I can lower the temperature of this water to the point that it becomes ice, and I put this glass on top, perhaps that I would be able to adhere the glass to the particle board and lift this whole thing at once, okay? Now, you can see that that's not really going to happen. And so I'm going to be mixing the barium hydroxide with this guy, ammonium thiocyanate, okay? The ammonium thiocyanate is right here. And notice that it too is a solid state, okay? It's a solid state. So what I'm going to do is I'm going to pour that in there. Okay. Nice and steady. The suspense is killing us. Okay. And I'm trying not to spill. Excellent. Now, when I put that in there, notice that I didn't add any water in there. And it's hard for you to see, but I'm going to take my stir stick and I'm going to swirl. Swirl. And here's what happens. When I swirled it, it actually is absorbing energy from the outside surroundings. And when it absorbs energy, it allows the solid state to become a liquid state, because you need energy to go from a solid to a liquid, okay? And so it's hard for you to see right here, but notice that it's actually turning into a liquid form. It's becoming very, very, very slurry, like a slush, like you see out in the snow on winter times. And look at that, it's really, really, really liquid state, okay? So it needs energy, and this is an example of an endothermic reaction, okay? It is very, very cold. By stealing the energy from the surroundings temperature is getting colder, that you could feel that it's quite cold actually. And I'm going to put a lid on top to capture all of that energy. It's very, very cold. Cold, okay? Now, it's so cold that it's able to freeze that water underneath. That water has become nothing more than ice. And it has allowed the glassware to stick or adhere to the particle board. you want to see how this works, let's take this, and I'm going to raise it up high in the air, okay? Raise it high up in the air, and look at that. Look at that. Okay? That is very, very strong. A very strong bond, and because the water has become ice, it stole all the energy when I mix those two chemicals. And notice that it's like a little liquid state. Now it's so strong that I could like literally rip this, and it's very hard to do, to separate it. I don't want to break the glass, but I want to show you how strong it is. I've got this kind of a hook here, and I'm going to add some weight. And if I add some weight to it, look what happens. Look at that. It's so strong, okay? In fact, I could add another one, okay? So if I add another one to it, look at that. Very, very, very strong. Now, this is a very good workout because I think that this is about 5 pounds worth, and I can really feel it in my biceps, okay? I can really feel that. But look how strong that is, okay? So, this tells you that this is an example of an endothermic reaction, and I hope that you enjoyed this experiment, okay? Very hard, okay? All right. Thank you very much, everyone. Mad Scientist Michael Wing.